Hi, and welcome to Go, Building DevOps Tools, Section 6, Writing the Core Library. In this part of the course, what we're going to do is we're going to develop the core of our pork tool. This is going to be the final part of the course, and the first thing that we're going to do is we're going to design the API. And so what we're going to do is just give you a basic overview of the architecture of the pork tool. And we're going to implement all of the interfaces that are going to be made use of when we do the implementation. Next, the largest part of this section is the implementation with NAP. And in this section, what we're going to do is we're going to take the NAP library that we had written previously, and we're going to use that to implement all of the interfaces that we created when we designed the API. So this is going to be where we're going to write all of the code necessary in order to make the pork tool work. And then finally, in writing tests, we're going to ensure that everything that we did works as we expected it to. Designing the API. In this section, we're going to design our GitHub library API. NAP is our library for interacting with REST APIs, and that's what we're going to make use of. We're going to use it in this section to interact with GitHub by creating a GitHub API layer. So what we're going to do is we're going to create a new API with NAP, and we're going to add resources to that API, and we're going to use routers so that we can parse the responses that we get back from GitHub and print information to the user or take actions. So let's get coding. Hi, and in this session, we're going to work on some of the features of the pork project. And we're not going to be working on the NAP integration yet, but what we're going to do is we're going to be implementing some of the features that are necessary to allow for us to work on NAP integration. So those things are configuration pulled in from configuration files, and then also we're going to need to work on the repository support. So in order to clone repositories, which is something that we're going to need for the clone feature and also for the fork feature, we'll need to implement support for cloning repositories locally to our system. So that's what we're going to start working on first. So what we want to do is to create a new file. We'll call it repo.go. And in this file, we're going to have a structure that we're going to call GitHub Repo. And GitHub Repo is going to have one public field, which is going to be the directory of the repository on local disk once it's been cloned. Then we're also going to store the owner, which is the GitHub owner or profile from where the original project was cloned from, and then the project name itself, which is under the owner. And then we're also going to want to add the repository, and in order to do that, we're going to be using a third-party library. So we're going to add it to our project. So this is going to add the Go Git project to our local vendor directory and add the library to our dependencies. And this will allow us to make use of all of the features that we need for implementing Git support. And now that we have all of our dependencies updated, we should be able to add the repository support. So here we are going to add the dependency, and then also we are going to add, and here I will name this Git, and then we will add support by adding a Git repository to our structure. So the next thing that we want to be able to do is to create a new repository. And the way that we'll do that is by passing in a repository string and then returning back to the user a GitHub repository and a possible error, because we're going to need to do some error checking. So what we're going to do is we're going to use the strings package, and we're going to split the repository string, and we're going to split it on /. And the reason that we're doing this is we want to be able to include the owner and project in the name of the repository, and then we can split it out into separate fields and put that into our struct. So what we'll do is we'll check, and if there are not two values, then we want to return an error. So that will inform the user of an error if anything goes wrong. And then here, what we're going to do is we're going to add the owner, which is going to be the first value, and then the project, which is going to be the second value. And then we're going to have a nil because in that case, there is not going to be an error. So now we've created our new GitHub repository struct. So the first feature that we want to implement on this struct is going to be the clone feature. And the clone feature will take a destination, and the destination is going to be a directory on your local disk where the repository is going to be cloned, and will return an error if anything goes wrong. So now we want to have the full repository path, and this is going to be the join of the destination along with the name of the repository directory, which is going to be the owner and the project put together. So there, now we have the full path to the repository. And then what we want to do is we want to be able to do a plain clone. And what plain clone is going to allow us to do is to provide a path of where we want the repository cloned to, and then we pass some clone options with the remote location, and it will clone our repository for us. So first, we're going to pass in our path, and then we're going to pass in our clone options structure. And so now in clone options, we're just going to pass the URL, and the URL is going to be from the GitHub repository object. We're going to call a method, and we're going to call it repository URL. Now we haven't implemented this method yet, but we will. So let's add that here. So repository URL will return a string, and that string will be the GitHub repository. And it will be based on the owner and the project. And so plain clone is going to return the repository, and it's also going to return a possible error code if we look here. And what we're going to do then is we're going to check the error, and if it's not equal to nil, then we'll return the error. Otherwise, what we're going to do is we are going to store some of these values, and first the repository is going to get assigned, and then the repo dir is going to get assigned to our full path. So now we have all of the values set that we wanted to get set, and we've verified that there is no error in the cloning process. So now what we can do is we can return a nil value. So now that we have clone implemented, we can try it out. So let's see if this is going to work for us. So we'll go back over to clone and see how clone repository is not implemented. Well, let's go ahead and implement it, or at least partially implement it now. So what we'll do is we will create a new repository using new GH repo. We will pass in our repository, and then what we'll do is we'll check the error code, and then if there is no error, then we're going to call repo clone, and we're going to want to call it on a directory, but we don't have a directory to pass in. So let's go back to the main in our program to determine how we're going to use it. So what we need to do is we need to add another dependency. So let's glide git, and we're going to get a library from GitHub called Viper. And Viper is going to manage our configuration. And we'll just run update to ensure that all of the dependencies are updated. And once this completes, we can add Viper support to our main program that will allow us to pull in configuration options from a configuration file. So now, what we can do in main, we can add the Viper library in the import section. And then in the init function, what we'll do is we'll add some support for Viper by adding a default value for the location. And the location is where we're going to store all of the repositories for this program. And so by default, we will make it our user's home directory. Viper will also have a configuration file that we'll call pork. And then we also need to add a config path, which we'll just call our local directory for now to simplify things. And then Viper will read in the configuration information. So now what I can do is I can create a new file, and I can call it pork.yaml. And I can add a location, and that location can be anything that I want. So I'm just going to set it to users/Matt. And so that's my user's home directory, and that's where my repositories will go. We're also going to add the token, which we'll be using later. And the token is something that you're going to need to retrieve from GitHub. And so once you're in your profile and you go to your settings and you go to private repositories, you can generate an API key or a token that we're going to use for doing the cloning and forking of repositories. But for now, we'll just set it to a default value. So now that we have the location value in place, we can go back to clone. And then we can use Viper and say get string location, and that will get us the location that we want to clone the repository to. And we should also check the error code and return the error if there happens to be a problem. And then we're going to return nil last if there was no problem. And we're also going to print out a message to the user. Cloned repository 2, and then we'll supply the repo directory so that they know where they can find the code that they've checked out. So let's see if this is going to work for us. So here we have a couple of flags that we've implemented, and then we have our clone command, which is going to pass along the arguments to our clone repository function. And then we've just put together a basic repository reference and whether we should create the reference in the repository. So we haven't gotten to the checkout portion yet, but we'll at least see if cloning the repository works. So the first thing that I'm going to do is I'm going to just ensure that I have cleaned up any previous repository I may have checked out, and then I'm going to attempt to use our tool and it looks like we have an error, which is probably just means that I need to make sure that I update my glide dependencies. So I'll fetch those real quick, and then we'll try again to see if that resolves the issue. And then once we're done with the clone feature, we'll move on to the checkout feature. And the checkout feature will allow us to check out a specific branch or even create a branch if one does not already exist. And it looks like it's probably going to compile for us this time. And we have an error. So repo says too many arguments to return. And it looks like there are 3 arguments here, and there should be 2. So let's see what happened. It looks like, yes, that nil should not be there. So let's see, and then this one says not enough arguments on 35. And it looks like there's an argument that was missed here. And we want to say false because we don't want a bare repository clone, a regular repository. So let's try that. And now we can say pork clone, and then I'll just clone the nap repository from GitHub, and then I will supply a reference, which we'll just say is master, and I'll supply the create flag. Neither of those 2 flags will be used right now, but at least we can see if it clones. And so it's telling us that it cloned to the repository mspalding06-nap, and if I look in that directory, it looks like it did in fact clone it for me. So great, that means that our clone feature works. So next, what we want to be able to do is we want to be able to check out code. And in order to check out, we need a reference, which will be a string, and then we also need a create bool, which will tell us if we want to create the repository if it doesn't already exist. So what we're going to do now is we're going to call and the repository, and we're going to get the work tree. And once we have the tree, we can do a checkout by providing options. So checkout options, and we can provide a couple different options. So we can provide a branch, and that's fine if we know that the branch exists. If we don't know that the branch exists, then we need to have a hash that we want to branch from. So that's the part that we need to do first. So before we can actually do the checkout from our tree, what we're going to need to do is we're going to need to determine what options we need to pass in the checkout options. So we know that we want to be able to pass the branch because the branch is always needed. So the branch will be our reference, but actually we're only using short references that we pass to the checkout, and we need to have a full reference. So we're going to slightly change this and make it refs, heads, and then the name. And that gives us our basic checkout structure, and we'll also pass the create option as well. And that Boolean will just determine if we're going to create the reference or not. And then what we need to do after that is we need to check our reference to see if it in fact does exist, because it is going to matter to us. So what we need to be able to do is we need to be able to say if create was called, then we need to change our options and we need to add a hash, and that hash is going to be the repository's head. So if I get the head of the repository, that's going to give me a head reference and possibly an error. And then the hash is going to be equal to the hash of the head reference. So that means that the top commit on the repository is what I'm going to use when I create my branch. So now what I can do is here, instead of passing the structure that way, I can use the ops variable that I created above, and then I can get the return status from checkout, which checkout returns an error, and I can just return the checkout. And so now we have a situation where we're able to check out or even create a new branch. So this should be all that we need to do to get checkout to work. So let's go back over to Clone and let's make use of these new options. So now that we have cloned our repository, the next thing that we're going to want to do is we're going to want to pass the reference and whether we should create or not. So these values should always be set, and if we go back to our command line tool, we should be able to see some default values. So ref we've set to nothing, and we'll make that master since it's common and expected that the default branch is usually master. And then create is set to false because generally we don't want to create the reference. So now what we can do is we can clone the repository, and before we print out that we have cloned the repository, the next thing we're going to do is we're going to check and we're going to check out the reference and we're going to pass in the should create bool. And we'll check the error. And so if the checkout does have an error, we will return it. And if not, then we will print that we cloned our repository to the user. And it looks like, so what we need to do is we need to have a reference name. So within the Git project, there is a type called reference name, which is essentially a string. And so here what we need to do is we need to cast the string that we've created to the reference name type. And so that's what we're doing here. And now we've compiled our project, and we'll make sure that the repository doesn't exist. And then we're going to call the same command that we called before. And it's going to say that the branch already exists because we're trying to create it. So if we remove the create option, it's going to say that the repository already exists because it already cloned it. So now let's try again. And it looks like we were able to clone successfully. And if I go into the repository, you can see that the branch is master. Now, if I wanted to create a new branch, for instance, I want to do some testing work, so I'm going to create a ref called testing, and then I hit enter. It's going to fail because I didn't pass the create option. Now, if the branch had already existed in the repository, then this would have worked correctly. But now, since it doesn't exist and I want to create it, I'll pass the create option. And again, it's going to say the repository already exists. So let's delete the repository, and we'll try this again with the testing reference and create. And now we can see that the repository was created. And if we go into the repository, we can see that the branch has been set to testing. So now the next thing that we need to do is we need to add support for remotes. So we'll do that finally. So now if we add another feature, and this time we'll call it add upstream. And then we'll just take a repository string, or better yet, we'll take another GitHub repository and we'll return an error if there's an error. And this way, what we can do is we can create two GitHub repository objects, one for the upstream and one for your own repository. And then we can pass the upstream in as a parameter to the add upstream function. So now what we're going to need to do is we're going to need to create a remote. And create remote takes options, and it needs a name, and it also needs a set of URLs. So first, we're going to create a string slice, and we're going to get the repository URL. And then we're also going to want to get the name, and that's just going to be upstream. And then here, we don't want the remote, so we'll use underscore, and then we'll get the error code back. And then we can simply check the error code if we wish, but I think in this case, it would probably make more sense just to return the error code. And I think that's what we'll do, because that will be simpler. So there, we'll just return error code, and that will allow us to add upstream. And we'll be using that when we implement the fork function in the next session. So now what we've done is we have created the GitHub repository structure and all of the functionality that we're going to need for our program. And then also in main, we've added support for Viper so that we can get the location. And then we're also going to add support so that we can get the token that's going to be needed when we make API calls. So that's all of the code that we need and the third-party dependencies in order for us to implement all of the features that are required so that we can go ahead and we can do integration with NAP and add all of the API calls. And that's it for this session.